No matter what your connection is to billiards, you can't live without the Porper Model B Q-Lathe. This is a great piece of equipment, solid die-cast steel, about 5 feet long, 150 pounds, and ready to go right out of the box. Whether you're an enthusiast, whether you're a hobbyist, maybe even a supplier, this lathe is a piece of equipment you can't live without. Going from square stock to finished Q in your own workspace, it's a must-have. The Porper Model B Q-Lathe, and today we're going to show you all the various pieces and parts of this lathe, show you how it works, what parts go where, and how you can make or repair your very own Qs in your own workspace. We're going to get started by showing the various components of the lathe. So let's get started with one of the most basic components of it, the chuck and the indexer. Ryan?
All right, what you have here is a 3-jaw bison chuck. It's already indicated out of the box, so that's one less thing you have to worry about. It's got 3 positions with the key, so you can open and clamp it down.
Just like putting a drill bit in a drill.
Exactly. If you can see here, this is the indexing head. It goes 360 degrees around in increments of 15 degrees.
Now, does this lock it into position?
Yes. This lever here has a set screw in the back. And you would start at 0, say if you had 4 points. So you would lock it in, your 0, top dead center here, and then you would go your 90 and lock it in.
And then just keep going around until
Yes.
you've gone 360 degrees.
Correct, for the 4 points.
Seems pretty simple.
It is.
The tailstock of the Model B lathe is solid die-cast steel and a very important component to this piece. Let's take a look at this and see what all this does and all the different components that are available for this. Ryan, what are we looking at here?
This is the tailstock. You can see that it's got the easy quick levers that you can just pull up and move into position and lock it
right back in.
Exactly. So if you unlock it, it can slide back and forth. Here we have the hand wheel that moves the quill.
Now there's a lot of play in this quill. How far out will this go?
It'll go 3 inches. 3
That's
inches
great.
of travel.
Now into this, and of course you lock that down here with this lever.
Yes, you can lock it in so it's not going to move.
Now into here we can put several different tools. Tell us about these tools and why we have this little flat spot here.
The flat spot is there so you can index it so it'll be with this set screw, so you can lock it in place so you're not burring up your tools, so it'll slip in easy out.
So with an Allen wrench you can lock it in. Tell me what this piece does.
This is a live center here for holding, centering a shaft or centering the butt of a cue depending on the process you're doing.
Okay, you can take that out. We've got 4 pieces that this comes with, so let's take a look at another one.
This is a tip centering tool. You can place your tip right in here, push it onto the ferrule, and it's glued on. You can put the pressure on it here, lock it into place. It's not going to go anywhere.
Going to hold it nice and solid.
Yes.
All of these pieces come with the flat spot so you can index them right in, right?
Yes. This is another live center here that would hold the tip of a cue when you're working on the shaft.
Okay, now here's a piece I know a little bit about. You're going to put drill bits in this, right?
Correct. You can hold your drill bits or center drills, any kind of tooling that you're going to need to be moving in and out and working in the spindle area.
You got a little chuck piece right here to tighten them down, just like you do on the power tools you have at home.
Yes, correct. This is included with the chuck, so it can just spin down and tightens onto your tool.
And so if you're making a 2-piece cue, you got to put the screw in there, the little bolt in there. This is how you drill that out and make sure it's nice and precise and dead center.
Yes, correct. This is all centered with the spindle and the chuck.
It's a great, important little piece of equipment here that we have on this. Solid too, so it's not going to go anywhere.
No, it's not, and it's already indexed with everything, so it's no adjustment needed. Virtually maintenance free, don't have to do anything to it. It's ready to go right out of the box.
And like we said, comes with all 4 of the pieces we just showed you, ready to start making or repairing cues.
Correct.
You know, the carriage table on this piece of equipment can be modified and quickly, like so many other pieces, to do so many different things. So many different tools can be added to it and taken from it in a very big hurry. Let's take a look at some of this and how it works. We'll start with the router. The block on the router will slide right into the channel here and hold that right on, but we're going to get into that a little bit more later. Ryan, you've got the tool post. Tell us about that.
The tool post will mount the same way that the router does. The block will go in there, it locks down, and it's ready to go.
And it comes with one blade.
Comes with the carbide face knife here.
And so Once that's on, you're all ready to start cutting.
Yes.
But there's some adjustments that you can make here in a couple of different ways. Tell us about that.
Yes, the table will move in two different directions. It'll move forward and back, which is called the Q axis.
Right along these rails.
Correct. And then it'll move the cross axis with the face knife here.
So that brings the knife in and out.
Yes.
Now, you've got index marks on here. Tell us about that.
Yes. Each mark here, as you can see, goes 4/1000ths of an inch per increment here.
And then you can lock it in right here?
Yes, you can lock it in, and as it goes up and down the rail, it'll stay true.
So true to 1/4000th of an inch, but the machine is actually capable of 1/10,000th of an inch, which is what, about a human hair?
Actually less than that, but
Wow.
yes.
You know, two other very important parts of this lathe are the bed rails and the feed screw. The bed rails, made of the highest quality steel you can get, keep the table running parallel and accurate. The feed screw is what moves the table up and down. And by the way, Porper is the only one that makes a feed screw with its own separate motor. That's very important to how this whole thing comes together. You know, so far we've looked at a lot of different components to this great lathe, but it all comes back to the control panel. Ryan, why don't you show us what makes this lathe run?
As you can see here on the control panel, as we said before, there's two separate motors that run the spindle and the feed screw. And you have controls for both. You have the control here that will turn the spindle on and off and forward and reverse. And then it can go the power level to increase your RPMs. Same with the feed screw. You have the on and off, the forward and reverse, and the speed control. Another feature this has on the panel is you can run it from the panel or from a foot switch once that gets plugged into there. The foot switch is set up on a rheostat, so the harder you push it down, the faster the spindle is going to go.
So there's really no way to make a mistake here. Everything's plainly labeled. The foot switch is easy to run. You can run this whole machine very quickly and very simply.
Yes, it is. It's anybody could do it.
You know, there's a lot of different tools that come with the Porper lathe, and a lot of these different components are what it takes to make the job right. So Ryan, let's go through these and take a look and see what all we have here.
All right, you can see here we have a couple of wrenches that we'll use with the router attachment.
Now what's this big piece here?
This is a steady rest, which is mainly used for working on one-piece house cues.
Okay, now I know this is an Allen wrench. You're going to use that to tighten and loosen different parts of the machinery when you're putting things on.
Correct.
What about this?
This is a dead center. Unlike the other ones we saw before, this one doesn't have any moving or spinning parts.
Okay, right here, these two.
We have two bits here. We have a spade bit and a V bit for cutting the points into the cue.
All right, and the brass pieces we see right here.
These are sanding mandrels, which come standard in the three most common sizes, the 3/8 10, the 5/16 14, and the 5/16 18.
Okay, when you put a piece of wood in here and you start turning the lathe, chances are it's going to flop around a little bit. These pieces here keep that from happening?
Yes, these are various collots that'll go onto the machine to help to not mar up what you're working on and to make things run true in the lathe itself.
Just keeps everything steady and keeps you from getting little tooth marks from the other pieces of machinery
Correct.
on your wood.
Yes.
Okay, and a sanding block, and what else do we have here?
We have a sanding block here that will help you sand and not get dips and everything in the wood, so you're not hitting one place too much.
Keeps it even.
Yes.
Okay, and this little bottle?
That tip touch is to finish out the tips and give you a professional looking job.
Everything you need to get the job done right.
Correct.
The Porper Model B lathe helps you keep all of your components where you need them. A built-in tray on top of the lathe with spots for extra pieces as you get them. Everything you need right where you need it. Okay, we've covered a lot of the different components to this lathe. Now, let's get into setup and adjustments. Ryan, you've got the tool post over there. Show us how that works.
Okay, like we showed before, you have the tool block here that would slide into this channel. And you want to give yourself, start it out arbitrary at first, and we'll lock it down.
That way it doesn't slide around while you're putting the actual cutting tool in.
Correct. So we take our carbide face knife that comes with the machine. We try to line it up so it's flush.
Then Allen wrench it down so that it's nice and tight in there.
Yes, because you don't want it moving when you're cutting.
Now you can actually, on this tool post, put in, what, 4 different tools, right?
Yes, 4 different tools.
Okay.
And I'll show you that function as we check the center height.
Now
here.
what's this? You're putting in a
This is our
centering
dead
device?
center.
Okay.
So we'll unlock it here, turn it around. Okay.
Now you want to make sure that this lines up dead center.
Yes, that's checking the center height, because if it's too high, it'll chatter. If it's too low, it'll chatter.
And kind of pull the wood back and forth.
Yes,
too,
it'll
right?
give you tool pressure. So then we can take a parting tool, which is going to be an optional piece, and we can put that on here.
Once all these tools are in place, to go from one tool to the next, you just need to turn the post.
Correct, yeah. That way you're not spending any unnecessary time locking them in and rechecking the center height all the time.
Sounds great to me.
So this we can take and turn around, and then
Lock
in
it
position.
in, and it should be right on center again,
Correct,
right?
yes. You can see that it's going to be right at center line. So
Perfect.
every tool you add in there will be on center line once you get the initial part set.
And then you're ready to get started with that.
Yes.
Terrific.
And you need to make sure that you have enough travel to be able to cut the part. So then you can adjust this forward and back, making sure that it stays perpendicular to your part. So now you see I have enough travel here to go across the part.
Looks easy to me.
It's very easy.
Okay. Okay, now we're going to talk about the tailstock, and there's just a couple of things here that you really want to pay attention to. Make sure you get them right. And let's ask Ryan how we put these parts on so that we make the right adjustments the first time. Ryan, one thing you want to do is really make sure that you pay attention to this flat spot, right?
Yes, we just wanted to reiterate the fact that's where the set screw goes. If you get it on the outside diameter of that live center, then you're going to have a burr and it won't want to come out as easy.
And right now it slides in and out with no problem at all.
Exactly.
Okay, now what about putting in the drill bit attachment? This is a little bit different. It doesn't have that flat spot.
Correct. This is a steel shank here. And so we want to hit where it's shouldered out here. So we want to get it in there, get a good tight fit on it, and lock it down into that position.
And you can kind of feel that as you're putting it in. You feel
Yes,
it kind of click into that.
Yes, you'll feel that step in there.
Super simple.
And the only other adjustment is when you're working on a part, make sure that you give yourself enough travel.
Now remember, we said there's 3 inches of travel in this.
Correct. So we just want to make sure that we're able to hit the depth we want to drill.
And you can just do that easily by moving it and locking it into place along those rails.
Yes, this bottom lever will lock into place. You can move it back and forth with ease.
There you go. With the business end of the lathe on this side, there's a lot of different options on this side as well for holding both shafts and butts solid while you're working with the lathe. Let's take a look at some of that.
First one we have here is an expanding collet. It can go on here. It's got soft set screws to go in. It's expandable to hold the shaft, either the collar end or the tip end.
That way you don't get any tool marks on this end of the shaft.
Exactly.
Okay, what about the butt?
Same kind of concept, just a bigger piece. Butt would go through here and slide in, and it'll hold as much or as little as you need. Soft set screws, once again, keeps it from bouncing around.
That way when you're turning it, it's not wobbling, causing you problems on the other end.
Exactly.
Okay. What else do we have?
We have a piece of optional equipment here. This is a secondary chuck.
Now this is quite the same as the chuck we have on the front end.
Yes, and this will sleeve on the same way. It'll go on, has soft set screws. And the reason you would want this versus anything else is when you're building cues, you want dead on precision. This is machine and indicated, so it'll work well with the front chuck, back chuck. Same type of key goes in, same principle. Well-made bison chuck. 3 jaws, just like the front one.
That's pretty impressive.
Yes.
Now we've got a couple other things back here too.
Yes.
This is a very long piece.
Yes, this is the steady rest, which is included with the machine. And I just want to go over briefly how to install this.
Okay.
First off, you're going to have 4 screws that are on the machine. So you remove those. And the key is to have this bar parallel to the floor and to the rails of the machine. To do that, you can see that there's 2 blocks under here and set screws under here on both sides.
So you can make adjustments.
Yes. So that way you don't want your bar sagging down or up too high, because that changes the angle of your working part.
So once you put in these 4 set screws,
yes,
then you can go underneath, maybe slide it to the end of the workbench.
yes, slide to the end of the workbench so you can reach those set screws.
Okay.
So let's put these in. If I can.
Now that we have it attached, what's next?
Okay, we have here is the other part of the steady rest. We've got some rollers here on an adjustable block, so it'll go up and down and move back and forth on the steady rest bar.
Now this comes with the lathe, right?
Yes, this comes with the lathe. And what you would do and use this for is if you had a longer piece, such as a house cue.
A one-piece cue.
Yes. You can take this out, run your piece in. Just sets right in the track. You don't need to over tighten it or anything. Just let it sit there and it'll roll along without putting any kind of marks or marring of the cue.
And holds it steady so you get precision work on the other side of the lathe.
Yes, and it's fully adjustable. You could hold the tip of the shaft if you wanted to, or you could come all the way out to its full length.
And hold the butt end.
Yes.
Okay, we've seen the components, we've learned about the adjustments. Now it's time to put this Porper lathe into operation. Let's get started, and remember, safety first when you're working with power equipment, so let's get those glasses on. Ryan, what are some of the things we need to know before we actually fire this up?
One of the first things you need to know is your spindle speed as it relates to the feed screw.
Now that's all variable, right?
Yes, different materials will need different ratios. Let's just turn this on so you can see the spindle speed. This is 50% here.
And that goes all the way up to 3,400 RPMs.
That's correct.
Now, you got to be careful though, because some woods, if you go too fast, you can wind up burning the wood.
Yes.
Okay.
If you go too slow, you'll end up getting chatter.
Now, once you have that moving, what about getting the table itself to move?
Okay, if I back this off, you can see this feed screw here. This is the feed screw set at 50%.
So that's also variable.
Yes,
Okay.
and they're independent of each other, which no other machine has.
Only Porper.
Only the Porper machine has
Okay.
this. Okay, you can see this dial here, this hand wheel that we talked about, and it's spinning by itself.
Yeah, and nothing's moving.
Okay, to get it to move, what you do is you could stop this, and you can stop it by hand if you're moving a short
So
distance.
just by taking hold of it, you
Yes.
can make it move.
Exactly.
What about locking it into position?
If I had a further distance to cut and I didn't want to have to hold it the whole time, I could
push it
lock it in. There's a peg here, and there's little holes on the back side, so it'll lock in. If you want it
Great.
to stop moving, you pull it out, it stops.
Okay. Now, what about loading in a piece of wood? Let's say, let's do a shaft.
All right, we have a shaft right here. We can take a measurement on it to see where we're at to start with. It's at 472 thousandths.
Okay, so you put it in the backside
I
here.
put it in the back, and I already have a collet on there to prevent the piece from flopping around.
Now, you'll see inside here little teeth on
Yes.
this. Now, if you clamp this down like you would a drill bit, you'd put tooth marks right into the wood.
Yes, and those won't come out. Even if you sand it out and you can't feel it, you'll still see it because you compress the wood fibers.
Okay, but there's a way to take care of that too.
Yes. We talked about the collets here. They measured out at 12 millimeter, so I want to put that in there, making sure not to chuck on the slot. Chuck that between the slot, and only have enough material out that you need to cut.
Because if you have too much out, you get a little wobble, all of a sudden your cut's not even.
Yes, because you're always adding tool pressure to it. So if you push it, it's going to chatter, going to be an uneven cut.
Okay, so loaded in here, you have a carbide cutter.
Correct. So what we can do is we can come up here, we can turn our spindle on. Since we're cutting maple, we want to get it up to about 80%.
Okay.
We can turn our feed screw on, and maple is a relatively hard material. So I think I'll turn that down to about 30%.
Because again, if you go too fast, you burn the wood.
Exactly.
All right.
So now let's get a touch on here to see where we're at. to get a starting point.
Now you want to do this kind of in layers, right?
Yes.
I mean, you don't want to try and cut it right down to the exact point all at once.
Exactly, because then you'll get too much tool pressure and it could be a dangerous situation. So what you can do is we touched off on it, gives us a 0 point. Remembering that each one of these slots here, or each one of these marks, is 4/1000ths of an inch. So let's say we wanted to take a 4/1000ths cut.
Okay.
We can do that. We can start it up.
Boy, that's fine. That is absolutely the finest powder I've ever seen come off of something. So now you're going to move in just a little more?
Yeah, I can reestablish there.
Okay.
And I would say you wouldn't want to take more than a 10 or a 12/1000ths cut on maple when you're doing
at any
something.
one time.
Something at that small of a diameter. So here's 12/1000ths of an inch. You get to your stopping point, you can back out.
And you're done with that part.
Yes.
Now, there's other ways to cut too, right?
That's correct. You could have it just pointing out here like this in order to cut a tenon for, say, a ferrule or a joint collar or even a butt cap. But sometimes you need to turn down the outside diameter of a joint collar.
Parting's real easy with this lathe too. Why don't we show how that's done?
All right. Here we have a piece of ferruling material. You can see that usually they come in rods and they're all oversized.
Okay.
So you want to cut it off to whatever length you want.
A workable size.
Yes.
Okay.
So you don't want any more out than what you actually need to use. So we'll just loosen this up, turn it around to our parting tool. You can see it's very thin at 100/1000ths.
Sure.
Let's just say we want to cut it off.
About an inch?
Yeah.
Okay.
At about an inch. Okay. We only need the spindle on this at about 70% for this type of material. Make sure you don't get your fingers in that chuck or near the cutting area.
Just that quick, just that easy.
And there you go.
There you go. When you're making a pool cue, you want a nice taper from one end to the other. You do that by adjusting the taper bar, and we're going to show you how to do that right now. We'll start on this end. You'll see 3 holes and a pin. This pin is actually going to be your fulcrum on this. It's your pivot point. You'll see the hole right there. You can adjust it in 3 different ways, and each way you adjust it is going to make a difference on how thick or thin that taper is going to be. For right now, we'll set it up right in the center. Once we get that set in there, then we can kind of move down to the other end and catch the other end of this, where Ryan's going to show us how to adjust that, and it's very, very accurate. Right, Ryan?
Correct. We have the tight down screw here that will hold it in place. So if you loosen that, you can see on both sides that they're set screws. You can turn that set screw, and you can see as the dial moves, you can do some real fine adjusting for your finished product.
I mean, right down to 1/2 or 1/4 of a millimeter in some cases, maybe less.
It'll read thousandths per inch.
Wow, that is accurate.
Yes, it is.
Now, when we do all of this, it changes the taper. So let's take a look at, let's start with the butt of the cue. And let's load this in. We've already got the router in place, right?
Correct.
So we'll center this up, slide it into place.
You lock the tailstock down, get a little bit of tension on there.
Now, if I want to make the butt end of the cue, the far end of the butt, a little bit wider, then how do I do that by adjusting the taper bar?
You would adjust the taper bar away from it. So in essence, you're pulling the cutter away from the butt of the cue.
And that leaves it wider on that end.
Correct. And since you're not adjusting anything on this side, you're keeping this diameter the same.
So you can custom build your cue for however you want it, whatever feels right to you or the person you're making it for.
Exactly. Gives you a wide range of measurements to use.
Okay, let's look at the shaft end of it. Now the shaft end cuts the opposite direction, is that right?
That's right.
So am I putting this in right?
Yes.
Okay.
This would be the joint end of the shaft, and this would be the tip end. You lock that into place, a little bit of tension, it's all locked down.
Okay, so now this cuts the opposite direction.
Yes.
Explain that to us.
The channel under here that we had cut and we showed you before, you would change the rollers out to go into that. And then that taper is set up to run in this direction. So you'd start down here, and if you wanted to make your joint size a certain size but a smaller diameter tip, you know, some pool players want 2 shafts on their cues, one
Sure.
at say 13 millimeters, one at 12. You can adjust that here so it would pull the cutter into the wood, into the cutting material, thus taking away more material.
And using that gauge, you can get it right down to the exact point you want it.
Exactly.
Easily done. Anybody can do it. Precision drilling is easy with the Porper Model B lathe, but drilling a hole in the end of a Q isn't all there is to it. So let's go ahead and take a look and see how this is done.
All right, we already have our drill in here. We made sure that it was on that collar and it was tightened down.
Okay.
I have a piece of wood in here that we just trued the outside diameter to.
Now this is an oversized piece of wood, so you don't have the little guard in there.
Exactly. It'll all be cut down to size, so we're not at risk of ruining the wood.
Okay.
So what I would do is turn the machine on. We're still working with maple, so we'll do about 80%. And what I want to do here is true up the face.
Now tell me what you're doing when you true up the face on this.
There's an imaginary line through the Q. It's the center line, or the Q axis.
Okay.
That's what makes a Q straight. And so what I'm trying to do is keep the face of this shaft perpendicular to that line.
So it's absolutely perfectly flat across
Yes.
the face. Okay.
And I'll show you why in a second. So what I'm going to do is make sure I hit all the way around, and then I can take a center drill here.
Okay.
I can put that center drill into my chuck here.
Now all these different bits that you're using, in, out, very quickly, very easy.
Exactly.
Okay.
So there I have it in.
Now this works kind of like a drill press at this point.
Yes. I want to make sure that I have this backed out of the way so I don't crash into it. Now since I'm drilling, I want to slow it down to about 40%. Okay, make sure I lock the tailstock in. I want to unlock this so the quill can come out.
And you've got that 3 inches of play there, so
Exactly.
you're utilizing that.
So what I'm doing is reestablishing the center of that Q axis.
So now we know exactly where the center is, but we're not
Yes.
done.
No.
Okay.
So the next thing we can do is put a drill bit in there.
This is a 3/8 inch.
Yes. And so we can turn that on. And then again, we're drilling. To allow the chips and everything to come out, you might want to go, between 30 and 40% on this maple. Because if it's too fast, it's going to burn.
Okay.
So what I would do here, you don't want to go in too fast either and get that drill bit to wobble.
So slow and easy does it.
Exactly.
Okay.
So we want to clear the chips.
Then back it out.
If you don't clear the chips, it's going to get hot.
And if it gets hot, it could burn or warp the wood.
Yes.
Okay.
What I want to do here is give myself a little bit more travel. And finish it off. And now I suppose you wonder why we put a 3/8 inch hole in the end of the shaft.
Well, now anybody that's ever taken a Q apart, you see the little brass threads.
Correct.
In there. So is that what we're doing now?
Yes.
Okay.
We'll need to tap out the hole. So we pulled out our 3/8 inch drill bit, put in this tap, so we can install this insert.
Okay.
It's the same thread pattern.
Perfect.
And what we want to do here, since it's going to pull by itself once I start those threads, so I want to give it the full 3 inches of travel here.
Okay.
Turn it on, keep it about 30% here. And give it a little bit there. Once it binds up, you can do it by hand. You can clear the chips out. Make sure the threads are nice and clean.
Because then when you put the brass in there, it goes in straight. And
Exactly. We can just clear those chips out. Run it back in. We'll start it out slow here. Finish it off by hand. Because what you don't want to do is keep the machine on and have this bottom out in the hole that you just drilled.
Because it'll pull in because it's threaded.
Yes.
Okay.
So let's back this out. Okay, then we would take out the tap. This is a pin setter here.
So this is what actually sets the brass threads into the wood.
Correct. And what we would do is lock that in.
Put the brass threads right on there.
Yep. Make sure we're forward. Slow it down. And then finish it out, making sure that this seats up against that new face that you just established.
Right in there, right flat against that face.
Yes.
All right. You know, sometimes when you're working with different materials, you need a larger diameter hole than your drill bit can handle. So the easy way to do that with this lathe is use the boring attachment. Ryan, I see you've got some different material loaded here. Tell us what you have.
Yes, this is the slotted ring here. We showed those wafers before, and what we have here on the tool post is the boring bar. You have the attachment here, with the boring bar here. So we just lock that into place, turn it on, go about 60% here. The difference between boring and cutting is we're moving the cutter out as we go.
Instead of going in, you're pulling it out.
Yes.
Okay.
So what we'll do is we'll find. Okay, now we've established a starting point. Make a couple of passes here. Taking a little bit at a time. 10 to 12 thousandths again.
So easy does it.
Yes. And so then what we can do from here, wait for it to completely stop, go in, we can take a measurement.
Make sure you've got the right diameter.
Yes. Okay, what we need to go to is 625, we're at 610.
So move it back in.
And remember, we're dealing the opposite way here. So we're bringing it out. And making the final cut.
So slow and steady. Pulls that material out of there. Once you have that done, use the parting tool, cut it off to the thickness you want or the thinness that you want, and you're ready to go.
Spin it back around to the parting tool, and away you go.
You know, the Porper Model B lathe really is an all-in-one piece of equipment right down to the sanding. Let's see how this works.
You see here we got a 14-thread insert, 14-thread sanding mandrel. So what we'll do is we'll just screw that in there.
Okay, and then you put that in the chuck, and that holds it nice and tight.
Yes, and it prevents you from chucking onto the finish of the shaft here.
Okay, now on the other end, we've got a different piece of equipment down here.
Yes, we went over the live center here. This is the concave center. So we'll bring that up, lock the tailstock down, give it a little bit of tension.
But not too much.
Not too much. And lock that into place.
Okay.
Then we're able to turn on the spindle and get the shaft to spin. Route around a little bit. You can just set that. And there you have it spinning.
All right, now you've got a special sanding block with some sandpaper in it.
Yep.
And what this does is it makes it nice and even, right?
Yes. We have the sanding block here. You can see that it's got a radius in here with a piece of leather. What that does is keeps you from putting too much pressure on any one point of the sandpaper. So you can come up onto the sandpaper with the shaft here. You can just come along, just back and forth in smooth strokes here.
And that just makes that so smooth coming across there.
Yes. I mean, it's really effortless.
That's easy. Now, what if you're doing the other end of the cube, the butt end of the cube?
Okay. We would take the shaft out. Now we need the female end of the mandrel.
Because we're going with the butt end, and that has the male end of it
Correct.
already attached, right?
Yes. So we'll screw this on. It's a 14 thread pin.
Right back into the chuck.
Right back into the chuck. Now on this end, you can see that we don't have the tip anymore.
Right.
So what we'll do is take this out.
But we still want to be able to hold this end steady, otherwise you get too much wobble.
Yes, so that's where the pointed center comes in. And we'll line it up on the flat spot there. Bring that up. Again, just make contact with it, tighten it down, give it a little tension, and you can turn it on.
So basically the same thing, just the other way around.
Exactly.
There you go. You know, when we say the Model B lathe can do anything, we mean it. And now we're going to prove another idea that you can use this lathe for, and that is putting the wrap on the Q. Now, Ryan, you've got a brand new piece of equipment here we haven't talked about yet. It's a tray. How does this work?
So here we have the wrap tray. You can see that I've already got a spool of white with green speck linen in there. Threads up through the hole. That way it's not going anywhere. And it just slips right over.
And that way it's not even touching the drive here.
Exactly.
Great.
And so what I need to do is we're going to use the foot pedal attachment here.
So you're going to go hands-free on the control panel, use the foot pedal to control your speed.
Exactly.
All right.
So here on the panel, we'll go from the panel to the foot switch.
All right, and I've got a Q butt here, so go ahead and show us how you put this all together.
Okay. It's a 14 thread once again. You screw that on so it's nice and snug. And into the chuck.
And you want to tighten that down.
Yep.
Okay, we'll move the tailstock in.
Okay, make contact, lock it down.
Just a little bit of pressure.
Yep, get a little tension on it. And then we're ready to go.
Okay, now there's a little trick that you have here to make sure that you can't tell where this wrap starts and where it ends.
Correct.
And that all starts with what, a power drill?
Yes, I got a power drill here.
Okay.
And what I'll do is I'll just, right up next to there.
Put a little hole in there.
Yep, just a
Now,
little hole.
Got to do one on the other side?
Actually, I will do two on the other
Two.
side, and I'll show you why when we get there. Opposite sides.
Okay. What's next? Glue?
Yes, just have some regular Elmer's glue here. Remember, I'm on the foot pedal here. So just a thin bead on there.
And just kind of use your hand as a guide to make sure it goes
Yep.
all the way down there.
Yep, make sure everything gets covered.
Okay. Little quick clean up here.
Yep. So then we'll find our hole.
Now what are you using there?
Just a regular toothpick, regular round toothpick. And I'll go at about a 45 here.
45-degree angle.
Yeah, away from the wrapping area.
And you just want to punch the end of that down into that hole?
Yes. If I can hit it in there. Okay.
There we go. Right in there.
So we put it in.
And you leave the toothpick in there?
You just break the
Well, just
toothpick
break it
off.
off.
So then what we'll do is we'll start the wrap.
Now, when you do this, you want to make sure that you're running the machine in reverse.
Yes, the wrap will be put on in reverse.
Because if you do it forward, the wrap goes clear off the other end of the
Yeah.
Q. You haven't done anybody any good.
Exactly.
All right, let me get my glasses on here. Okay.
So I'll switch the panel to reverse. And I've got the foot pedal. Remember, the further I push the foot pedal down, the faster it'll go.
And so it just kind of follows down there on its own.
Yes. And sometimes it'll jump off. That's not a big deal.
So just back it off a little bit.
Back it off to where it jumped, because sometimes there's imperfections in the linen that'll cause that to happen.
There we go.
Yep. So then we'll just go a little bit here. Maybe move the tray over a little bit.
That way you've worked your way past that little imperfection that was in the linen.
Yes, that's why we rolled it by hand just a
Okay.
little bit. Now we'll go kind of slow because the linen has a little bit of glue on it. So once I get past that, get going again. Okay.
And with the foot pedal, you really control the speed, so you're not going too fast, not going too slow.
Exactly.
Just keep it nice and even. And with the foot pedal, it allows you two hands. You can move the tray and make sure you hold on to that linen.
Yes.
All right, get right down to the end.
Right there.
Now, we had 2 holes in that side, and you're going to show me why.
Yes. So that way it's easier for me to find, you know, I want to push it back a little bit, tighten it up some.
And you do that with the string itself.
Yes.
Okay.
So there's the second hole. I get another toothpick, and I get this one right up against there. Push it down in. Just making a little loop in the linen there. Push it down in.
Okay. Get out the X-Acto knife.
Yep.
Trim the linen off. Snap off the toothpick.
Okay. And to finish it out, you see we have a gap right here.
Yeah, just a little bit.
So we'll push this wrap.
You're just using a screwdriver for that.
Yep, just any round utensil here. We'll push it up. See how we pushed it back to find the hole. Now we'll push it up so it's seamless. You know, and if we get any gaps and things like that, we can move it up and down the wrap itself also.
Because that glue, the Elmer's glue, leaves you a little bit of leeway to do that.
Yes. You can see here's where we started. So we'll push that up, over, and cover that.
Now that the wrap's on there, you have no idea where it starts or where it stops.
Exactly. So to finish it out, we'll introduce another piece of equipment here.
That's a different looking tool. Now, this is something that's optional. It doesn't really come with the machine, but this makes your life a little easier.
Yes.
Okay.
This is the Presser Pro, another Creative Inventions product. So we'll go back to forward. We can spin this, and what this allows you to do is see your working area here. You see how it's just pressing the excess glue out.
So just by squeezing those handles together, these rollers, as you move across, are squeezing the excess glue out of it.
Yes. And so you don't want to roll up onto the finish of that Q.
Because you could take the laminate off.
Yes.
Okay.
You can go up and back a few times.
Now, other products that do this don't allow you to actually see where you're working, so you run the risk of knocking the laminate off.
Yes.
That's what makes this particular tool so unique.
So then you let that dry. There's several ways to finish it out, whether you use a polish or a cornstarch or whatever to smooth that out after it dries.
Look at that. That's beautiful. Nice job.
Thank you.
You know, the Model B lathe will take you from start to finish on any Q, and when you start with a square block. You can turn it into one of these, a perfect toothpick, each one just like the next, accurate to 1/10,000th of an inch. But if you want to avoid the toothpicks, Ryan's going to show you how to turn this into a Q. Ryan, what do we have here? What kind of wood is this, by the way?
This wood here is Bacote. It comes from Central and South America. So what we're going to do is I'm going to show you how to set up the machine in order to turn the square to the round.
Now we're going to do this with the router.
Yes, the router attachment here.
Okay.
First thing we're going to do is the router housing would go in here and mount on. But just so you can see what I'm doing, I'm going to turn it around for you.
Okay, so this way we can see how the router slides in and how to center it up.
Yes.
Okay.
So with the included wrench here, we'll get this. We'll tighten that down so it's not going to move anywhere while we're getting our adjustments.
Now the router and the sleeve both come with the machine, right?
Yes.
Okay.
Here's the spade bit, which is included with the machine, and this is what you'll do your turning with.
Now, anytime you're working with a router, putting in a bit, taking out a bit, you want to make sure that router is not plugged in.
Exactly. Anytime you have your hands in this area, you need to make sure that the router is unplugged.
Okay.
So we'll take our wrenches here also that are included with the machine and just snug that in there.
You want to make sure that's good and tight.
Yes, because you don't want it spinning if it's too loose.
Okay.
So we'll take the router and slide it in here. And because of the versatility of the machine and the router, what we need to do is check the center height for different tools. Okay, so we'll back this up a little bit and try to make sure that it's about in the center of that spade bit.
Okay.
What we could do from there is lock it into position. To make sure it's not going to spin in that housing.
All right.
Okay, now let's turn it around.
So get it actually in the operational position.
Yes. So you want to make sure the opening here is kind of square and parallel to everything here. That way you get optimum working distance.
Perfect.
Okay, if I can just lean in here for a second.
Use the wrench to tighten that down. You saw how that was done before. So
Yes. I
there
just
you
want to
go.
make sure it's not going to slide. Okay, make sure you have a good working distance here. And since we're going to be running on the taper bar, we need to disengage the table again
Okay.
and lock this in here.
All right.
And it's set up on the straight taper because we're going to cut a straight taper onto this piece of wood.
Okay. Now, you got to mount the wood to the machine.
Correct. So what we'll do is remove this center here. We have another optional piece here. This is the square to round.
Okay.
So you see it's got a little point in there. I've already put a small point into this wood here.
That gives you your center spot.
Yes. I'll take that and just tighten it down.
So that actually grips onto the square wood now.
Yes.
Okay.
Okay, you see there it's not going to go anywhere. So this we put into the chuck. Now you come down to this end with the tailstock.
You've got another hole here.
I've got another hole on this side. Make sure I've got a working distance here. So put that in. Give myself enough room for this router to fit in here. Lock it in place. Give it a little bit of tension. And it doesn't have to be a lot.
Just enough to hold it.
Yes.
Okay.
And so then we can start the machine.
You want to put your glasses on for this, don't forget.
Yes. And if I can I have you plug it in? There's a plug on the back side of the machine for the router.
That makes it easy because that's very convenient. You don't have to go looking for another plug.
And that way you can't run each piece independent of each other. So that's a
Got
big
it.
safety feature that's involved here.
All right.
So we can turn this on. Now when you're turning wood, you don't want a lot of speed on it. This here is running about 30%.
And you don't want to take off all the wood in one pass either, right?
Exactly. I mean, a piece like this, you'd have to make several passes to get it down to a workable size.
Okay, well, let's show a pass here. People can see how this operates.
Okay, so we're going to need our feed screw on. We've got that at about 40% also.
Now remember, the feed screw and the lathe operate on two separate motors. That way you've got total control.
Exactly.
Okay.
And so what we have here is we've got it set at about 40%. And again, each wood is going to have its own characteristics. So it may have a different setting for each type. So now we'll come in, turn the router on.
And you want to come in just till it makes contact, right?
Yeah.
Okay.
Okay, now I've made contact. So let's run a full 20 thousandths on this.
So you can see it's not taking off a whole lot right at
No.
first.
What it's doing is you want to knock the corners and everything off of it and take smaller pad. You can take, once it's round, you can take bigger cuts.
Okay.
Now we're going to have to stop it before it gets to here.
Okay. Now can we back it off and take one more pass?
Yeah, if we wanted to, we could back it out, roll it back.
Reset it. Little fine pieces of dust coming off there, and that's what you want, not big chunks.
Yeah, you don't want big chunks. If big chunks, you're taking too much of a pass. Okay, we'll back it out, shut the router down, and we'll see where we're at.
You can see we've already taken off the corners here.
Yeah.
So it's not as square a piece of wood as it was. And how many more passes would it take to actually get it down to around, I mean, approximately?
I would say you could take 2 or 3 more passes. Each pass you go, you could take a measurement, see where you need to be at, and adjust accordingly.
So then after a few passes, you've gone from square to round. You're on your way to making a Q.
Yes, it was very easy, very self-explanatory. It's just that easy.
It just works.
Yes.
You gotta love it. Now we're going to move on and show some more work with the tool on the butt this time. And Ryan, we've already got a piece mounted in here.
Yes, we got the piece mounted. You can see that we're going to cut from right to left because of the way the taper bar is set up.
Now we've reset the taper bar.
Yes.
Because we're working on a taper, larger diameter on this end, smaller diameter here.
Yes, so we've exaggerated the taper, and that way we can get the diameter that we want.
Now if you have any question about how to reset that, you can refer back to the taper bar section of this DVD.
What we'll do is we'll get everything spinning again. Just like before, we'll come in and touch off.
Easy does it, right?
Yeah. Lock that in position so it'll hold the same setting all the way down.
And again, you don't want big chunks. You want just a little at a time.
Yes.
And you can see the difference in color from where it's been to where it's going.
Yes.
And that's really all there is to it. Just continue your pass down to the chuck, check your taper, make sure your measurements are okay, take a second pass or maybe even a third pass if you need to, and you've got it done. You know, once you've turned the butt, time to turn the shaft, and we've got a shaft all loaded up here. We've made some adjustments too, right, Ryan?
Yes. We've moved the taper bar back to the center position. And I've also taken the rollers and moved them from the inside straight taper to the outside compound taper.
Okay, and this side's all calibrated down here. So
Yes.
we've got the router all set up. This time we're going to move in the opposite direction.
Yes, when we're turning shafts, the compound taper is set up to run from the spindle to the tailstock.
Okay.
So again, we'll start the spindle. Now we're going to move the feed screw in reverse, going away from the spindle. So we'll turn that on. Get in real close there. We can lock it in.
And just
away
like
it goes.
everything else, easy does it. You don't want to take off too much at one time.
Exactly. You can see the difference here where I touched off and started
Right.
for how much we're taking off.
And after a complete pass, you want to calibrate it, make sure you've got the right measurements.
Yes.
Make a second pass, as many passes as you need to get it down to what you want.
Yes. You can see how it's taking that little bit of a wobble out, and on this side we have a nice straight shaft.
Right. And right there where that wobble really was, you're seeing it's taken off just a little bit more.
Yes.
And that's what's going to eliminate that wobble.
So we'll have to stop it before it gets to the center there.
Okay.
So we'll stop it, turn the router off, back it off a little bit, shut everything down and take a look.
Boy, that's smooth.
Yes, and you'll be able to tell with different woods. If you start getting chatter, you may be going too fast with the feed, you may be taking off too big of a pass, or you may not have the center height. So it's a matter of experience as you go.
And easy does it. Don't take off too much all at one time. Make sure you get it just the way you want it. That's the precision beauty of this.
Yes, you can always take wood away, you can't ever put it back on.
There
So
you
you want
go.
to take it slow and easy, and that's about what it is.
Time to cut some points, and points is really what makes your Q look professional. We're going to get a different setup here, even with a different router bit, right?
That's correct. So we have a 45-degree bit here, and that will cut the pocket that we glue our block into.
Now when you put this in the router, again you want to make sure that router is unplugged.
Yes,
Then you want to make sure that the cutting points match up in the center.
correct. We'll put it in there, and I'll make sure when it's in there that it goes point to point. If it's off in either direction, it's not going to cut your points correctly.
Okay, while you get the router set up, let's take a look at some examples of these points.
All right.
What we have here is a 16-point Q. This is very intricate, but nothing that this Porper Model B lathe can't handle. Look at how beautiful this is and how it flows through there. Now this is going to be a little bit more intricate than what we're going to cut today. What we're going to work on today is just a very simple, let's get a 4-point here. Take a look at that, where we inlay the different woods together. And that's what makes these Qs look so professional and so slick. I mean, this is a great way to go about putting together a Q and getting that professional look when you're done.
All right, here I have a bird's eye maple blank that we've already tapered with the machine. No different than cutting the full length butt.
Okay.
So we'll load that in here, bring the tailstock up. You want to snug this up. Again, not so tight, but tight enough. Then we want to start out at 0 here.
Now we're doing a 4-point, so you want to divide that by 360.
We're going to divide this 360 by 4, which will give you 90. So we'll start at 0. So we'll engage this here, make sure it's up there nice and snug.
Okay.
And then we'll find out where we're going to touch off with the router. If you can plug that in for me.
Right back into the back of the machine.
Okay, now for this operation, we will have the feed screw only, which is a feature exclusive to this machine. So we'll turn our feed screw on, and we want it to go forward towards the spindle. We'll do this at about 50%. What we can do here, we'll start it off at 0, so we have a reference point. Engage the router. And as it cuts in deeper, you may want to slow the feed down because you're taking off more material.
Okay. Just like anything else, if you go too fast, you can burn the wood.
Exactly. So we can back that out and see that we've cut one of the 4-point blanks. See, now we can dial it in and cut that deeper, or if you wanted a longer point, that's all in the adjustment of the taper bar. So you can cut a shorter, thicker point or a longer, thinner point, depending on the number of points you want.
So once you get a point cut in, move this by 90 degrees, make
Yes.
your second cut.
So we would pop this out here, just knock it out with. So then we go to 90. Make sure that's up in there really snug. Come back, engage our router, get the feed screw going. And remember, you can adjust the feed screw speed on the fly. So as it's going, you can slow it down or speed it up as you need.
Okay, so now we've cut some points in there. How do you get the inlay in?
What we would do is, obviously these aren't deep enough yet. You may want to take a couple of passes at it just because the amount of material.
Right.
And you can make your adjustments as you go also. You could cut the 4, and if you want them longer, you always have your index head here so you know where you started, you know where you finished. So what we can do is we would take this out. We have just a block of Bacote here, and this would get glued into that spot. Okay, then we'd get some epoxy,
Glue it in.
glue it in, and then you could put it back in here, have the spade bit back in the router, turn it like you would the butt of the Q, and you could show the Bacote 4-point blank that we have here. This one's Coca-Cola. You can see how you get all 4 pieces in there.
Once you round it off, it's nice and smooth. You're well on your way.
Yes, makes everything very easy, very simple. Once you have your centers established, it's always going to be on center, so the length of your points, they're going to be sharp, and they're going to be all the same length, which is very important when you're making cues.
If you take a look at the end here, you can see how deeply these channels were cut and how when this inlay is put in, how deep that goes. That's a great looking professional job of cutting points. So far, we've used the Porper Model B Q-Lathe to do everything from going from a square block of wood to creating a cue, even making those great cuts in there for the points. Now we're going to use it to do some finishing touch work. Ryan, looks like we're ready to do some tip work here.
What we're going to do here is install a standard tip and ferrule.
All right.
So we'll turn our spindle on, and just make a couple of rough passes here.
Just a little at a time.
Just a little bit at a time. And so what we want to show here is that the inside depth of our ferrule is about 775. So we're going to cut this tenon to right about 3/4 of an inch or 750 thousandths.
Now you can do that with this machine because it is that accurate.
Yes, it is. So we'll go back on. We can make a cut. Take our steel ruler here. See, we still have a ways to go.
Now how far down do you want to take that?
We'll take it down with a threaded ferrule like that. It's going to be pretty close to 1/4 of an inch.
Okay.
Okay. So now we know how far we need to go towards the spindle. So now it's just a matter of taking our small passes.
Sneak it in just a little bit.
Yep. It's about 10 or 12 thousandths at a time.
Well, you can really see how fine a line that is.
Yes. And remember, each line is 4 thousandths of an inch.
If you tried to take it all off in one pass, it'd just snap the wood.
Yeah, especially with a smaller diameter piece like this. You'll know if you're going too fast or you're taking too much by the sound it makes and the type of cut it's making. If you get chatter or the wood starts to fray, then you know you're going too fast or taking off too much.
You're being a little heavy-handed.
Yes. One more quick one here, then we'll take a measurement and see where we're at. To our mark.
You know, there's really such an art to making a cube, but this machine kind of blends the artistic interpretation of it with the scientific precision of it.
Exactly. So we can take a measurement here. See that we still have a ways to go. We're about 370 thousandths.
That's exactly what I was thinking.
We'll just take a few more quick passes here.
That's why Ryan has to keep calibrating this and checking the measurement on it, is because the cut we're making is so fine, you can't possibly see it with a human eye enough to gauge it.
And one of the things in cue making is you want all your parts to fit tight. So you need an accurate machine to do that. If you make too gross of a cut, it's going to wobble and it's in the end going to fail.
How many times have you picked up a pool cue at somebody's house or someplace else and you strike a ball and you hear that little rattling noise?
Yes.
It's because the parts aren't fit together properly.
Okay, a little bit more here.
You hear how soft that blade is against the wood there.
Yes. Wait for it to stop. Take another measurement. I'm going to make a pass. I'm going to show you something before we get to this type of a ferrule.
Okay.
There's two basic ways that the ferrule is held on. This one is threaded on the inside, and we'll put threads on here to screw it on.
Okay.
Another is extruded with the hole completely through it. And that way, it would just sleeve over like this.
But that's nice and tight. There's no give in there.
Yes. So there's just enough room for the glue.
Wow.
So we'll get that one out of there. You can see the difference. So we're going to continue to this diameter.
So we can actually cut threads with this machine.
Yes, and another thing, you know, with this sleeve-on type ferrule, it's the same thing if you're going to cut, you know, a joint collar for your Q, just different measurements, different diameters.
Different material.
Or if you're replacing a butt cap, you know, it's just going to be a different diameter, a different depth, but it's all the same function.
Okay.
So let's keep going here. Okay, let's take a look again, see where we're at. We're almost there.
Just another thin hair.
Yep, should be just one bigger pass and one really fine one, just to clean everything up. What I'm going to do here is face that off so it's nice and square.
You can look on here and see how much of that we've taken off with just a few passes.
Yes. So what we'll do now is we have the Porper threading tenon here.
Now that's something we haven't looked at yet.
Exactly. This is an optional piece that you can get. And what it'll do is it'll come on here.
And just by turning that by hand.
You can turn it by hand or use the chuck. I believe it's a little safer doing it this way, especially since I have the cutters and everything so close
Sure.
in.
But that's actually putting the threads on there.
Yes, and it's not cutting the threads, it's a compression die, so it's actually pressing them into the wood fiber.
Squeezing the wood fiber together.
Yeah, and that makes it stronger. Okay, we'll go all the way down until we hit the face of that Q.
Then back it off.
And back it off.
Yeah, look at that. Perfect threads right across.
So we have the threads inside of here. We'll just make sure that our depth is correct. And see how there's no gap in there.
Perfectly flat all the way across.
Exactly. So now what we're going to do is, since it's got a nice tight tolerance, it's nice and tight to get back off, is we're going to get a little bit of glue in there.
Just to hold it firm.
Okay, here we just have a little bit of wood glue. We want to make sure we get all the surface of this tenon.
So just run it around through those
threads.
through the threads with your finger that way.
Then I'll take a little bit and put it in here. And any excess that we have will be pushed out this hole here. And we want to get that on fairly quickly.
Before the glue starts to set up a little bit.
Yes.
But it doesn't dry completely instantly either, does it?
No, it'll take a couple seconds for that wood glue to set.
So we'll take a couple of minutes here, let that get set up, come back and finish it off.
All right.
The glue on our ferrules had time to set up now, so let's move on. The next thing we want to do is face this, right?
Yes, make sure everything is flat and square. So we'll just turn it on. Clean the burrs out. And now we can go to our tip centering tool.
Now this comes with the machine?
Yes, this is standard with the machine. Goes in here, flat spot with the set screw here. And what we'll do is get a little bit of glue here and put it on the tip. And we'll put it in here. And put it right there. Give it a little pressure. You can see how the glue is
kind of oozed out the edges there just a little bit.
Just a little bit. Clean that up so it doesn't drip on our machine.
Now what this does is it makes that tip dead center on the end of that Q.
Exactly. You know, some tips have a dome on it. Some don't. This is a flat laminated tip. So it's got a flat surface. So it'll seat right in there, either type of tip. And one of the great features about this is it's a non-reactive plastic. So the glue won't stick to it.
Wow. So now we need to give this a few minutes to set up?
Yes.
All right, we'll do that. We'll be back to finish that tip. We've given some time for the glue on the tip to set up, and I think we've accomplished that, but we've got a little bit more cutting to do, right?
Exactly. So what we'll do is we'll back this out. See the tip is on there. You notice that everything is still oversized.
Yeah, the ferrule and the tip are just a little bit larger in diameter than the end of our shaft.
So what we'll do is we'll cut those down to size. And again, we'll get it going. Need to make a touch contact there.
We're talking about what? Maybe a millimeter here?
Yes, a lot of things come standard at 14 millimeters.
Okay.
This is a 13 millimeter shaft.
So we need to just trim it down by 1 millimeter.
Yes.
Probably take, what, another pass?
It might take me 2 or 3 down.
Okay. Precision really is the key here, and that's why this particular machine is so valuable.
Yes, and that's why I'm taking a little bit smaller passes than I would on the wood, because I don't want to take too much and hit the actual shaft.
Boy, we're getting close.
Yep. Take a quick measurement here.
Now think about that. We're talking about 1 millimeter that we have to take off of this thing. We've already made, what, 3 passes?
Yes.
And you know a millimeter isn't a whole lot of material to take off.
So as you can see, we have about 20 thousandths. So we can do that in 2 passes, 10 thousandths each.
Now before you start that, let me just run my finger across there. Yeah, you can still just barely feel a lip there. Okay.
Okay, this will be the last one. Stop right there. Now, as you look at this, do you think you could just chalk that up and play pool?
I don't think so, and the reason for that is this end is flat.
Okay, so what we'll do now is introduce you with a tool that you haven't seen yet.
Okay.
This is the the cut right cutter for the tip.
So this puts the rounded end on the tip.
Yes, you can see it's got a removable blade. It's in here, And you can adjust the radius of a tip. Some people like a nickel, some people like a dime, by moving this cutter here.
So just as precise as the rest of the machine.
And I'll show you exactly how easy this is.
And this is an optional piece.
Yes. Loosen that up a little bit. Make sure we get it on that collet.
Now I'm told that this will do it perfectly every time.
Every time. So what we'll do is we'll come in. I can take a look here. And we'll just get close to the tip, running at about 70%. And we'll just, let me back this out so I have a little more travel.
There we go.
All right. We'll do.
And again, you want to take just a little at a time here to make sure it's nice and smooth.
And each tip has its own characteristics, so it'll just be a matter of experience to know how fast and how much you can cut on each one. This happens to be a laminated tip, so we want to just be a little bit careful not to separate those layers.
I'm seeing to get that nice domed curve on there already.
Yes. Back that away and we'll see where we're at.
That's nice.
So now we can finish it out.
So there's still just a little bit left to do.
Yes.
Okay.
We'll get a little bit more speed here. We'll just get some sandpaper.
Now why sand it down? Just to smooth it out and get
Just
the
to
burrs
smooth
off
it out, and what it does is it burnishes the tip. Keeps it from mushrooming and just failing altogether. So just get it smooth. We don't want to really hit that wood. We just want to make it a little bit smooth. This is a 600 grit sandpaper.
That's pretty fine.
Yes. We don't want to take a lot of material away. I mean, we cut this at 13 millimeters.
Sure.
That's what we want to keep it at. And to do the finishing touches here.
Now what's this? A little bottle of what?
This is Tip Touch, another creative invention. Let's get a Q-tip here. Get a little bit on there. We just put that right on the outside of the tip there. What this will do is just help seal the tip and keep it from delaminating and mushrooming.
So you have a little piece of leather.
Yeah, just a piece of leather. And this is just burnishing it out.
Wow.
You can take that piece of sandpaper here, just clean up that dome.
Look at that. Perfectly smooth, nice dome, finished tip. What a great job.
It's ready to shoot pool.
If you're looking for one great piece of equipment that does it all from start to finish for Q repair or for manufacturing Qs, you found it with Joe Porper's Creative Inventions Model B Q-Lathe. Everything you need, all the options in one box and ready to go right out of the box. Make it Joe Porper's Model B Q-Lathe